The session for the afternoon is broadly on topics related to innovation and peer review. Clearly, we've already heard some discussions about changes in scholarly publishing in journals and in other forms of publishing, and some mention of peer review or no peer review or associated metrics about evaluating publications, but the session here is really focusing in more detail on that issue, which we think is really important related to publishing. So our first speaker is Victoria Stodden from Columbia, and I don't know what your title is, but I'll let you do it.
I put all my slides on my website, so if you have an iPad or your notebook and you want to follow along, you can just find them on my website. So reproducibility in science, why all the fuss? And I'm going to try and motivate this concept of reproducibility that we actually saw quite a bit of discussion about in the panel before lunch, and tie this into peer review and how these are very closely related topics, and also, of course, peer review has more in it than reproducibility, which we'll hear from for the other panelists. Okay, why all the fuss? So this isn't something I don't think that is new to this audience. The changes in technology that are driving a lot of the way that we're thinking about how we communicate all sorts of scientific research. What I think may be new for people to think about is, instead of just some underlying change or the advent of the internet, there's actually, I think, a very precise way to conceptualize some of these changes, and thinking about them in sort of these three different categories I'm going to explain to you, I think may actually help some of our discussion about review. So the first one, everybody knows this, I won't spend much time on it, is we're swamped with data. Data is now digital, and this is opening all sorts of new possibilities and creating new opportunities and new concerns in how we communicate and how we review scientific publications. The other one that people talk about, although I don't hear as much discussion about it as the data issues, are the massive increases that we've seen in computational power. So this is doing things like permitting us to simulate an entire physical system, changing a parameter, resimulating it again. It goes in some sense hand in hand with very data-driven research, especially with very massive big data, but it is in its own right changing how we communicate computational science, the types of questions that we're asking, and the types of evaluation that we need to apply to this type of work. The third one, which I hear almost no one talk about except this morning, people started talking about this, is, I think, another new change in the technological underpinnings of scientific discovery is now very deep, bona fide scientific contributions, real intellectual contributions to science, are appearing only in the software. So I'm a statistician, and many of our methodological innovations are now in code. They can be described in a paper, and sometimes when they're applied, they're not even actually described. You have these innovations existing only in software now. Okay, so what's this rationale behind reproducibility that people were talking about before lunch, that is now something that you've probably even heard about in the popular press? We have, of course, this notion of skepticism. We don't take things on faith necessarily, although no one has time to necessarily replicate everything that is in front of us. But this skepticism means that we demand that claims become independently verified before we start to allow them to modify our understanding of what may be right or what may be wrong in the world. So that, as has been established over hundreds of years, has led to a much more transparent communication system in science. In fact, you would say that scientific communication is different from other sorts of communication because of this issue of transparency. So that's a picture of Robert Boyle there, and he was the first one, you know him from chemistry and Boyle's law, and he was a real figure actually in many fields in science. In the 1660s, he was involved in these discussions in the Royal Society when they founded the first journal. He was the one who really kind of said that trying to replicate experiments without all the full details in the paper, even understand the paper, isn't sufficient. What we need to do is have those details in there so we can really go through the thought process. So science became, instead of a discussion about what is in the world or what the facts are, it became, here's what I think might be true and here's how I got there. So really more about the thinking and the thought processes behind it. So if you keep that in mind and then you start thinking about intellectual contributions embedded in code, you can see there's really been a big shift. Okay, the scientific method. So we structure much of our communication, including review, around these notions of the scientific method and how we actually organize the process of discovery and also dissemination. We've had two branches for a long time, back to actually 1660s, maybe further back, depending on what historical records you respect. But regardless, we have the deductive branch of scientific discovery. You recognize this in mathematics and in logic. And then we also have the empirical branch, sort of the inductive branch of scientific discovery. For example, statistical analyses of controlled experiments. And that's typically how we've been progressing in scientific discovery. Most of the work that we've been doing over the last several hundreds of years has fallen into one of those two categories. Now there's a lot of discussion over the last, say, 10, 15 years that we are actually innovating new branches of the scientific method due to these changes in technology like computation and data. So large-scale simulations, is this a third branch of the scientific method? Data-driven computational science, this is now a fourth branch of the scientific method. And so we're sort of thinking about these innovations as expanding what we understand as science. So the argument I'm going to present to you in my less than 10 minutes is that computation, as it's instantiated in the scientific discovery process, is really only comprising a potential third or fourth branch of the scientific method. We need to be developing these standards of communication and of review for computational science. So I throw this up there not to kind of single anyone out, but the picture on the left, if you can see, it says it's from 1995, and you can kind of, you just know someone did that HTML by hand. So modeling and simulation in NIST multi-laboratory strategic planning workshop. And I pulled the quote that's in there and put it on the bottom. It's common now to consider computation as a third branch of science besides theory and experiment. 1995, people are talking about this. And again, just as a representative example, 2009, this is a Microsoft Edition collection of like an edited volume talking about data-driven discovery as the fourth paradigm of computational science, or of the scientific method. So there's lots of kind of discourse around how do we even define science. Okay, and if we think about why do we even have the scientific method? The reason we have the scientific method is because error is present everywhere in everything we're doing as scientists. Both of the original branches, first and second branch of the scientific method, they've developed standards, communication procedures to try and combat this. You don't come up with a mathematical proof and try and publish it with, a mathematical result and try and publish it without the proof. Aside from the fact that you wouldn't get very far with journals, intrinsically you know that's just silly, right? Why would someone believe you? And secondly, wouldn't you want someone to check your work and make sure these proofs made sense and your result was correct? In the empirical branch, there's an entire machinery around hypothesis testing, a very structured way that you communicate methods and protocols. In many journals, they have a deliberate method section, and it's understood what you're going to report in there. These two branches have had hundreds of years to come up with these communication standards. Computational science, as I mentioned, is maybe 15, 20 years old. We're still thinking this over, and I think this is a current that was running through the discussion this morning and through these larger discussions around scientific publishing. So we can move away from computational science sort of giving demos or showing the cool stuff they've done with data to really similar to these mature branches, something where there's transparency, there's the ability to replicate these results and extend the results and really understand the how, not just the what. At that point, I think we can say they're really bona fide third and fourth branches of the scientific method. So I believe data code access typically, there may be well-reasoned exceptions, but typically is important and it may be essential for scientific integrity and review. Okay, we already saw this, the Economist picture. So over the last year, these are all from, I think, within the last 6 months, possibly within the last 4 months. There's lots and lots of discussion around these issues of reproducibility. You can see Nature, Science, Economist, they mention reproducibility in Economist and so on. If you were sort of a more casual observer, you might think really we were in the midst of a credibility crisis here. I think the same way we can break down the changes in technology, I think we can break down usefully how we think about reproducibility rather than as a blanket term. So all of those sort of discussions of nature science, and largely what the Economist article was about, is reproducibility in the empirical sense, actually still in the second branch. So they're saying there are problems with the way we're communicating science today, but they're not really new problems. These are problems that maybe are coming to light through greater access to articles and more rapid communication or a variety of other reasons, but they're really not fundamentally new changes. This is in the second branch. So I just called this empirical reproducibility to try and distinguish it. And Science had an article a couple of weeks ago on new standards for publication in that journal, and they're concerned with preclinical work. They're all concerned with the second branch, all empirical reproducibility. How are you reporting? Then there's a work that I've been engaged with, which is, I guess I'm starting to call computational reproducibility. How do you get code? How do you get data? How do you verify results that have some computational component in them? This doesn't just mean scientific computing on, petascale massive machines. It goes right down to someone who's using their laptop and Excel in their work, and doing very small scale science as well. All of this is subject to these same standards around computational science. They may be tweaked a little bit, but all of this is coming under review and revision and people rethinking about it. I think the third way to think about reproducibility is when you can't replicate a result because you don't have the statistical information that you need. There's been either poor statistics or things have not been reported properly. So I've been calling this statistical reproducibility, and there was just in 12th of February, you probably saw this article, actually by a friend of mine, Regina Nuzzo. We were grad students together at Stanford, Scientific Method Statistical Errors, and she's pointing to some of the reliance, say, on p-values that may or may not be something that actually has the value that you would think it is. And if you read her article, you'll probably be convinced it does not have that value. Okay, the other thing I wanted to just mention to you is that this isn't a discussion that's happening in the abstract, in the air, in this room. This is something I've been collecting little pieces of information, and I put in red some of the fields and areas that are thinking about these issues. They're putting together workshops like this. They're putting together discussions, seminars, thought pieces. How do we tackle these issues of reproducibility? And they're all over the map. You can see computer science, applied math, geosciences, bioinformatics, high-performance computing, and largely they don't know what the other ones are doing. These are all happening in silos. They've just come to the realization it's something that needs to be tackled in that field. Oops. Okay, so integrity in publishing, this sort of begs the question now, as at least for the computational work, how does it get communicated? Who reviews these computational findings? I think if you asked someone, perfectly smart person outside the field of scientific research and discovery, they would have an assumption that when work is published, someone's checked those computations. It's been reviewed, right? It's not true at all. Very, very rarely, there's like a handful of cases I can think of where before publication, someone's actually dug into the computations in that paper. Most of it is scanned for that seems reasonable. Okay. So that's a huge gaping question, I think, thinking about how review changes as the technology and the scientific process of discovery changes. Where does this responsibility for checking these computations lie? Maybe it shouldn't be checked before publication. Maybe it's okay to just look it over and say, that seems about right. Make sure you get your code and data out there, and then that happens post-publication. That's actually the approach the second branch has taken, which is nobody gets into a lab and replicates the empirical work before it's published. Other scientists do that, and they find flaws, and the dialogue continues. It's not the approach of the first branch where proofs are checked before publication. So this is another open question that we have. You do some replication, let's say it's post-publication, and you check someone else's work. How do you get that information back out to the community? There isn't a good place to publish replication studies. Maybe that's something where we need to be thinking more in a Git model, where you fork a scientific result, and then that's actually tracked online, and you can actually see the work and the dialogue that's been happening around that particular result. There's many new models we can think of. Who's reviewing the code? Before lunch, people talked about how do we know data has integrity or is even coherent. It's not like a bunch of jumbly bits. The same thing for code, and the standards are very different in how you might review code. And what even are those standards? What makes good code that's reusable by others? Scientists have never been developers, and we didn't sign up for that. We might make toys that we can get out there, but at what level? Clearly what we're producing now is not something people are, generally speaking, that comfortable sharing, or it's not that useful. How do we sort of start to move towards something that's easier for people to produce and easier for people to use? Another interesting thing is we are allergic to plagiarism in science, as we should be. With code, in a sense, you want people to plagiarize your work. There's no reason for me to take your code and make small changes so that it is just exact. No, I'll run it exactly how you wrote it if that's right for my purposes. I should be citing you, I think, and the same with data. But our standards, again, of misconduct and what's right and wrong, code starts to break those and make us ask questions about what we're doing. Who's responsible for all of this? For data integrity, for finding fraud, for falsification in data? We have some standards around this. What about issues in code? Where do these sort of, where does the responsibility lie for making sure all of this kind of makes sense? Statistical issues that I mentioned earlier, so this is now in statistical reproducibility. File drawer problem, we've heard about this before lunch, so people doing a lot of work and then they publish the one that actually worked. Okay, so statistically that's a very bad idea. Lots of antiquated experimental reporting standards. Do we know what happened in experimental design or how many different things were tried before they settled on the one that worked, and that may be perfectly legitimate, not just sort of statistical cherry picking? A lot of that's left out. The methods section that I mentioned earlier is really short. So maybe that's something to be rethinking when we want to allow people to review the work. Different fields are very, very different in terms of what they use, what they produce, what their standards are, what the standards need to be. There's certainly not one size fits all. It probably goes even down to very small disciplines. That's something where it's a barrier for all of us thinking about how we move forward on this, that there needs to be that tight connection with grassroots efforts in the field. Okay, I'll just wrap up after this. I'll very briefly touch on some of the efforts and solutions that are happening. There's some work on best practices that are coming out. So I apologize that actually 2 of my papers are sitting on there, which is disgraceful. But in a hurry, I just put things out there to show you that there's discussion on best practices in both computational science. These are mostly computational science, but also around empirical research as well. The discussion is starting in statistical reproducibility as well. Lots of discussion this morning and ongoing around tools. I do firmly believe, without question, that improvement in our computational tools for the computational reproducibility branch is extremely important. I grouped these, so this is an incomplete list. Of course, it's growing. And I grouped them basically into 3 different places where the tools are making a difference. Dissemination platforms, how do we communicate code, data, and so on. And by the way, these are hot linked if you want to check this stuff out. Some of them are unbelievably cool. Pre-publication, workflow tracking, research environments is another area where there's lots of growth in tools and helping people track their work so that they can get onto those dissemination platforms and communicate it. And then there's kind of a hybrid between the two, people who have systems for allowing you to write papers that have the code and data embedded in them, almost executable papers. So there's lots of activity here. Most of them, I'll have you know, are being created by academics just sort of on the side of their research. It's really amazing. Okay, so I just wanted to mention another lever is what journals are requiring. I won't go into the details here. I'll leave you to check it out on my website. But I was interested in what are journal requirements around code and data disclosure. And the take-home message just from this slide is it's getting better. There's actually, from 2011 to 2012, there's been movement in these journals that I haven't really explained to you what journals they are in computational journals, towards greater requirements on code and data disclosure. So you would think, or at least I would think a priori, that it's tough for journals to react. They have committees, they all need to agree and so on, but they actually are reacting and they're taking it seriously. Same with code. Code's lagging data, but it's again increasing as journals are adopting code disclosure standards. The biggest one, of course, is Science, that has a code disclosure policy. This morning, people mentioned the last year's executive memorandum directing federal funding agencies for science to come up with plans on data disclosure and access to publications. And I mentioned in that executive memorandum, there's actually verbiage that data is defined as a digital factual material commonly accepted in the scientific community as necessary to validate research findings. So they had something in there that, at least through my lens, reads a little bit about transparency, about review, and about scientific integrity. I also want to mention on May 9th, there was an executive order. Now the federal agencies have to release their data as of May 9th for their, their internal research. Okay, funding agencies themselves have long-standing policies around expectations for data sharing, code sharing. 2011, at the beginning, NSF instantiated their data management plan. Some solicitations have a software management plan. Now, I've particularly seen that with NIH. So the funding agencies are starting to kind of monolithically creep towards this issue. And this is my last slide. I wanted to leave you with a National Academy's report sharing publication-related data and materials, responsibilities of authorship in the life sciences. I'd like you to note the date, which is 2003. So more than 10 years ago, their first principle, authors should include in their publications a data, algorithms, and other information that's central or integral to the publication. That is, whatever's necessary to support the major claims of the paper and would enable one skilled in the art to verify or replicate the claims. It's a transformative discussion we're having here today, and new in many respects, but it's also part of a longer conversation that's been going on for over a decade in the sciences. So I'll leave it here and move to the next panelist.
No, I do not want to join MobileNet. All right, our next speaker is Emily Ford from Portland State University. I don't know if that didn't get cut off on the side. Talking about her studies of open peer review.
Hi, everybody. Do I need to pull this down? It's not made for short people. So if nothing I say makes sense, I'm going to blame the cold medication. Just a forewarning. So please ask questions at the end. But I want to kind of frame a little bit why I was asked to talk here today. My job description, obviously, I'm a reference and instruction librarian. That's where Urban and Public Affairs, I work with the College of Urban and Public Affairs at Portland State University. But open peer review has been part of my scholarly agenda. I'm formerly a scholarly communication librarian, so that research agenda has stuck with me as I moved on in my career. I am also the founder, a co-founder and editorial board member of a journal or blog turned journal that uses an open peer review process, or what we consider to be an open peer review process. And I noticed it sounds a lot like the curated kind of method that you talk about for LIM, so I was really interested to hear about your journal. So, open peer review. Honestly, talking about this in less than 10 minutes feels really absurd to me. So please write down your questions and ask later. So I think it's important that I define what I'm talking about today, but that's also really problematic because there is no common accepted definition of what is open peer review. In those journals and those societies that are talking about open peer review, none of them are implemented the same way, none of them are approached the same way, and none of them are defined the same way. My operating definition that I present in the paper that was published in July in Journal of Scholarly Publishing, more on that in a minute, is that I approached it at a very basic level. Open peer review for me meant if there is at any point disclosure between an author and a reviewer of those identities. At any point. It could be after publication, signed reviews up on the web like we have with BMJ, or I don't know if BMJ puts them on the web, but BMJ does have signed reviews. We're probably going to be hearing about the probably most transparent publishing open peer review model is Faculty of 1,000 Research that I've seen. So I hope we hear more about that. But my operating definition is just disclosure at any point. So what I did was then actually think about what are the common characteristics of what is happening in open peer review, and the paper is actually more of a systematic review, so I looked at all of the literature about open peer review. It's very, very meta. But these are the common characteristics that I kind of came up with. Signed, pretty obvious. Disclosed is disclosure at any point prior to the publication process. Oh, are you laughing at the picture? I'm surprised no one has had that yet. I'm actually really glad I was the first one to get that. So yeah, peer review Godzilla. Editor-mediated review. So any kind of editor mediation, and we heard about this a little earlier, where I forget who it was, talking about the screening process of data or whatever gets published, so things get screened. So that is a part of editor mediation that happens in open peer review processes. Some processes are, open peer review is opened for a while and then closed, and then editors make final publishing decisions, right? Others are different. There is some form of editor mediation. So editors, you still have jobs, at least for now. Transparent is very rare. There was one journal that, Atmospheric Chemistry and Physics, is probably one of the first journals that was using open peer review in general, and it claims to be transparent. I would say that it's not, according to how I've defined it. Crowdsourced review, so that's like pre-publication, preprint server, comments, etc. So kind of like you'd have in Public Library of Science or PLOS One. You have the commenting capability on PeerJ and F1000 research and stuff like that. Pre-publication makes sense. Synchronous publication is only in concept has that been discussed in the literature in terms of open peer review, and then post-publication. So those were the common characteristics, and there are a lot more examples about it in my paper. So where are we going with open peer review? And I think this slide points to all of the many, actually there should be many more arrows and many more question marks up on this slide if we're talking about where open peer review is going. I have absolutely no idea. I can talk to you, however, about what the trends are. I would say that among all of the characteristics, editor-mediated review was probably the most common characteristic in any implementation of open peer review that I have noticed. There seem to be a lot of beta tests with open peer review. So Shakespeare Quarterly has had a few beta tests. Paul Graves Macmillan right now has an open peer review book project just announced, I think, a few weeks ago, right as I got this cold, so I don't know enough about it. Don't ask me. Let's see. I'm working with college and research libraries, the publication of my professional association, to try an open peer review experiment. Like I said, atmospheric chemistry and physics is actually set in stone, but I think mostly things are beta tests, and that's how they're being framed so that communities can kind of buy into it and get to it. And I think there's a trend also in that those journals that are experimenting with open peer review are also those journals that are pushing the envelope in other areas, right? So they might be membership-based publications like PeerJ is. But one thing I do want to make sure that I stress and clarify is that when we talk about open peer review, it does not equate open access publishing. They're actually separate. They happen a lot of the times in the same journals, but they don't necessarily have to. Shakespeare Quarterly is not an open access publication, for example. Okay, so finally, I want to talk about some challenges, and I'm going to kind of take, please forgive me for being a millennial and talking about myself, but so I won the Mendeley, there's a group that's the Open Access Irony Award. And the paper that I published this stuff in with these characteristics won the Open Access Irony Award. And, it hurt a little bit. It stung my heart. But I think one of the problems is that I'm a tenure track assistant professor, and I have to deal with a promotion and tenure committee. I don't know who's going to be on that committee. I honestly don't know who my dean is going to be when I go up for tenure in 2017. I don't know who my provost is going to be in 2017. And also, I live in Portland, Oregon, and I have a union represented job. So those are things that I'm not really wanting to risk. So I published in a journal that wasn't open access. But what I did do is it took me about 3 months to get a license agreement with a publisher that was acceptable to me, where I retained my copyright. And the paper's in our institutional repository, so I feel a little bit better. But I would just use that example as one of the main challenges is the academic culture of promotion and tenure. And I'm falling into that same paradigm, and I think we all agree on that. I would say that the acceptance of open access, as Heather mentioned this morning, the rate is astonishingly small, right? So I think open peer review is like open access on steroids almost. So if scholars in our communities aren't accepting open access, how are they even going to accept open peer review? So I feel like it's pretty radical. And I would say it's more in the life sciences than in the humanities in general, with the exception of Shakespeare Quarterly and Kathleen Fitzpatrick's work. There are differing needs in different disciplines, and I think that's a major, major challenge, because what you need in atmospheric chemistry and physics or in the life sciences is vastly different than what you would need in history or the humanities, social sciences. And then I have two more thoughts to share with you. One of the other challenges is developing the systems that would actually enable open peer review without a lot of people touching lots of things. So we need people to be creating systems like OJS or something like that that would actually facilitate an open peer review model and make it easier. And then finally, I think one of the biggest challenges is that we're talking about open peer review within a traditional publishing paradigm. And honestly, I don't know that we can consider what used to be published as published anymore. And so if we're looking at open peer review within this framework, it's kind of doing it an injustice. And maybe we just need to get rid of what it means to be published in general, and maybe just get rid of the idea of peer review altogether and come up with new terminology to talk about it. And finally, you can access my paper on our repository, but if you want to read more about open peer review,
Open peer review, but closed web system.
Closed web system. There is a great bibliography that was just published a few months ago that has almost anything you could ever want to read about open peer review listed on it. Thank you.
Are you connecting to the web at all? The web? Okay. I'm just going to turn it off. I wish I had said that if I say anything strange, blame it on the cold medicine, but I haven't taken any, so it's just me. All right, next up is Ivan Aransky from NYU and a group called Retraction Watch, which I believe you started and co-founded. And he's going to be talking, I believe, about retraction and peer review. I don't know. Do you want me to do that? Or?
I can do it if it's here. Is it here? Or is it?
It's lost the mirroring, too, here. Here, I can do it.
There we go. Thanks, Jonathan. And I guess Adam Marcus, who's my co-founder, he and I are now a group. We've sort of moved from just being a couple of guys with day jobs to a group with a couple of guys with day jobs. So it doesn't really help our tax returns, but that's okay. So I wanted to talk to you, and thanks very much to Jonathan for the very kind invitation to get out of some really lovely weather we've been having in New York. My wife is giving me updates as if to taunt me or something, or reverse taunt me. I don't know how that works. So I wanted to talk about the experience that Adam and I have had with Retraction Watch in terms of looking at the literature from a pretty narrowly focused point of view, and that's, of course, on retractions. And in fact, one of the things that some of you may actually read the blog, and thank you for that. It's you and my mom. My mom only sometimes, but you may have noticed we barely stray away from actual retractions. We get a lot of emails and contacts and people saying, would you please cover this because it really should be retracted? And a lot of the times they're right. I mean, in fact, a lot of what they're writing us about is stuff that deserves to be retracted far more than some of what actually is retracted, and that's maybe a discussion for later too. But even sticking to retractions, we can't quite keep up, and I'm going to talk about why and sort of some I think lessons with a lowercase l that we've learned through time. So I want to start with a story. I mean, Adam and I are journalists. We tell stories. We don't really collect data, although people have used Retraction Watch for data, to sort of to look at various trends and things. We're thrilled by that. But I'm really good at the anecdote. For journalists, as you probably know, data is actually data are the plural of anecdote. So I'm good at that. And I want to start with a story that some of you may be familiar with. After we wrote about this got picked up in the Chronicle of Higher Ed. That's a very clever young man named Hyung-In Moon, who's a plant researcher in Korea. Hyung-In Moon is so clever that he came up with a very smart system. He really wanted to get some papers published. This is publish or perish after all, and so this is, I think, uniquely relevant to what we're talking about. So what he did was he submitted a whole bunch of papers, and he submitted them to journals that he knew where the publisher would ask him for suggested reviewers. And so when he was asked for that, he gave a couple of names, and he would give names, and let's say that this somehow had something to do with work that Jonathan Eisen was doing, he would give, John J. Eisen at UC Davis studied you or whatever it is, except he wouldn't actually do that. He'd give J. Eisen, Red Sox stink at gmail.com. Sorry, that was just a dig. There was a tweet earlier about my Yankees fandom, so I had to get back at John there. But so so the peer review requests would go out for this paper to J. Eisen, whatever I just said, at gmail.com, and J. Eisen would write back a lovely review and very appropriate sort of, this is a great paper, and I really think you should publish it. You should fix table 1 because it looks like you inverted your axes or did something, or you have a typo on page 4. Your conclusion, tweak this, blah blah blah. But great, definitely, minor revision. Please go for it. I want to see this in literature. Well, who do you think actually had control over J. Eisen at gmail.com? It wasn't Jonathan Eisen. It was actually Hyung-In Moon. And what nailed Hyung-In Moon, the way that he published, by the way, he eventually published 28 papers this way, okay? Just let that sink in for a second, 28 papers. He actually had on Retraction Watch, we sort of talk about a rap sheet being how many retractions you have. He actually had a rap sheet before this episode, which we learned as we were reporting the story. He had retracted 7 papers. I know there's someone here from Elsevier. Actually, they were Elsevier papers that he retracted earlier, not for this reason, but for other reasons. And so what happened was the editor kind of realized something strange was going on. Not so much because they were all positive reviews. The papers, as far as we know, and we're not experts in this area, were actually pretty solid. There was nothing particularly problematic about them. But all the reviews came back, okay, within 24 hours. Right? That's right. You can't get people to agree to review a paper in 24 hours, let alone actually do a proper review. And these were good reviews, let me tell you. This person knew these papers better than anyone this reviewer had ever seen. So I think the story, obviously it's fun. It's a nice little story to tell and maybe wake people up in the late afternoon. But more to the point, it speaks to a lot of the pressures. The system in Korea, I don't want to make vast generalizations here that aren't true, but there are plenty of similarities with the systems in the West and other places in terms of the amount of funding and the shrinking funding and the competition and the pressure to publish in certain journals. And so that's really, I think, what that's about. So some actual, I guess I would call these data. This is actually taken. Neil Saunders is a bioinformatics guy in New Zealand who actually this is one of the many things he does for fun, so we appreciate that. And this I grabbed, if it wasn't yesterday, it was the day before. I think it was the day before. So it's more or less up to the minute. And not to go through the numbers in any detail, but the thing that's clear, and I don't know if you can read everything on this actually, but on the left, this is from PubMed, and these are retraction notices. Publications on the left, so you can see from 0 up to whatever, 1.4 million. And on the right, and I can't read it because it's so small on the screen, it actually says retraction notices per 100,000. So we all know that, we've read and Nature wrote about this a couple of years ago, based on Thomson Scientific data, that the number of retractions actually grew tenfold between 2000 and 2010. Okay, but so did the number of papers. But actually, the number of retractions vastly outpaced the number of papers. So there are more retractions per capita, if you will, per 100,000 papers or whatever your unit is being published. There are obviously any number of reasons for that, some of which are maybe obvious and wrong, and some of which are probably obvious and right, and then others that we're not thinking about yet. But people have been looking at this. And one of the papers that came out, you may be familiar with this one, this came out in October 2012 in PNAS. The three authors have written a lot about retractions, a lot of really important work. And this is sort of in the canon, a pretty limited canon of retraction literature, as it were. This is probably the most important paper so far. Excuse me. And so they actually looked, and what they found was that whereas when you look just at retraction notices, and people had done this, in fact, Grant Steen, the second author, had done this, when you looked at retraction notices themselves, you would think that fewer than half of retractions were due to misconduct or some fraud or misconduct, okay? When they actually looked at retraction notices plus secondary sources, I mentioned that people have used Retraction Watch as one of these secondary sources, so that's included in here, ORI, Office of Research Integrity, investigation reports, other media reports. They found that 2/3 of retractions were due to fraud. So, which suggests that some of the stigma attached to retractions, which is really, to me and Adam, one of the big problems, is probably correct, is that the perception that retractions are almost always due to fraud, or that there's something really bad, there's kind of a stink attached to it, a stench, that probably has some external validity. The other thing that we've seen is these massive numbers. Diederik Stapel came up over lunch, and he's pretty impressive in terms of retractions. He's retracted 54 papers, but he's really a piker, and he will never actually reach, unless he goes back and publishes lots more papers. This is the current record holder. The number 2 record holder, who was quite upset, I'm sure, when Yoshitaka Fuji broke his record. Both of them are anesthesiologists. In the interest of time, I won't concern you too much that maybe you should, I don't know, think twice about that surgery, which you'd probably do anyway. Not so much for the surgeons, but for the anesthesiology, for the anesthesia. There are some reasons for that again, and be happy to talk about them. But my point here was to say 183 retractions by one person, even spaced out over a couple of years, we're talking about 500 a year, give or take. That's a big chunk. So doing any kind of analysis of why retractions happen, anything like that, you can do it rigorously, but it's fraught because you basically have one person responsible for, again, depending over how much time that takes, at least 20%, 30%. This is a paper by Grant Steen, just to show you how long they take. And I think this is relevant to the whole notion of post-publication peer review because, that line, it dipped a little bit for some reason, but keeps going up. There's some evidence actually that that's leveling off and that you're seeing a sort of bimodal distribution where a lot of recent papers are starting to get retracted very quickly. But also what's happening is that editors are going much further back into the literature. The current record is 27 years. There was a paper retracted, which is pretty impressive, I think, and not in a good way. But it took 27 years to retract a particular paper. And it wasn't for anything terrible. It was for duplicating a paper that had been written like 28 years before. I mean, it was, I don't know, but anyway. A lot of journals, again, and what Adam and I are chiefly interested in is transparency and in correcting the scientific record in a way that actually says something to people who read it, which is obviously scientists, but lots of other people too. We've certainly heard a lot about open access today, so a lot of this is open to the public. And a lot of retraction notices, getting back to what I was saying about that study, don't say why something was retracted, or they're actually misleading. And it's hard to not imagine, even if you're not as cynical as Adam and I are, it's hard not to imagine that they're not intentionally misleading. These are editors, they're publishers, they know how to write in whatever language they're writing in. They should know how to speak write clearly. And so this is one example, the Journal of Neuroscience, and actually John Monsell, who's the editor, he's up at Harvard, he's quite upfront and transparent about why his policy is the way it is. But the policy is basically if an author wants to retract a paper, John will just let him retract it without having to say why. And you'll have a one-line retraction that says this has been withdrawn or retracted by the authors. Adam and I are, we sort of find that problematic. And a good example of why is that we found out why a paper was being retracted, not because of the journal, but because one of our readers, who's in Japan, actually translated a whole bunch of media reports in Japanese. It turns out that the person who had retracted it had done so in advance, as an investigation was going on, so that the record, if you will, doesn't reflect the fact that there was misconduct or investigation going on, but I just decided to withdraw it because maybe there were some problems with it. And that, we don't think, is the best way to correct the literature. Moving a little bit to, I'll go through some quick examples here of the kind of post-publication peer review that Adam and I are seeing. I wouldn't say we're exactly part of it, but we certainly are covering this. I'm sure you're all familiar. If you're not, certainly I'd recommend checking it out with PubPeer, pubpeer.com. This is one example that kind of put PubPeer on the map for a lot of people. There was a Cell paper. Sorry, I keep picking on Elsevier, but it happens. The Cell paper came out, really remarkable in terms of the speed in which it was published. The turnaround from, I mean, this would make Young and Moon jealous. The turnaround from submission to publication was 4 days of a Cell paper. And this was, you can see the title there. It's, again, a study that actually everyone knew somebody would do, and somebody did, and it should get published, and somebody wants all the citations from it. I get it. But what happens on PubPeer, which is anonymous for the most part, is that people write their comments. And so just within a few days, you had this comment, which Adam and I have learned, this is the sort of academic way that people, if you'll forgive me, I know many of you are academics here, sort of stick knives in one another's back. You don't say, this is crap, or this is really problematic. But you might, there are several images of imagery use which might be of interest. This is sort of like when you're a person of interest, and for the police. Quickly, just so basically, this is according this story considerably, but this actually led to a correction, a pretty substantial correction in Cell quite quickly. This was a couple days afterward. I won't, and I'll put my slides online. I haven't done that yet, but I'll do that. I'll put them on SlideShare. Some of the comments that Emily Marcus, who's the editor of Cell, made when we asked and other outlets asked, others were certainly all over this story as well, about this, we thought were pretty telling, and actually it's the next one that's in particular. And I think that last sentence is a misrepresentation to equate slow peer review with thoroughness or rigor, or to use timely peer review as a justification for sloppiness in manuscript preparation. It's sort of having your cake and eating it too. Don't blame us because we didn't give anyone enough time, but the editor, the reviewer should have pushed back and said we need more time, even though they knew they couldn't have gotten more time. I mean, it's a sort of bizarre thing where we've, again, shrunk the amount of time people have for peer review so drastically. Again, I'm sure you're all familiar with the fact that PubMed now allows comments. Adam and I have some criticisms of the way they did that, but then again, Adam and I have criticisms of pretty much everything. So the bar is kind of, where it is. In general, though, we think it's a really good thing. Our concern is that not everyone can comment on PubMed comments. I'd be happy to have that discussion too, but it is pretty important. I'll leave you with some good news, though, which is that scientists seem to actually reward transparency. So contrary to what the concerns seem to be, that if you say too much in a retraction notice, if you're honest about something going wrong, you're screwed. You will be penalized. In fact, it appears, and this is one study, so let's be really clear. It was done by economists. They've done a couple other interesting studies about retractions. There's actually an association between more citations of your previous work and an honest retraction. That's kind of cool. I mean, the assumption would be, or the null hypothesis, I suppose, would be if you retract a paper, people think you're sloppy, you don't do a good job. They're going to look askance at other papers, even unconsciously. But actually, if you're honest about what happened, it's an honest mistake, and you make that clear. In fact, you get a bump, the Colbert bump or something like that. And that sort of is why Adam and I actually wrote this together, but for some reason only my picture's there. We actually think more retractions might be a good thing, and not just because, we like to write about retractions. We can't keep up with them anyway. But if retractions actually say why something is retracted, that's a pretty good thing. And then I'll just leave you with, I'll really leave you with this time. There is one way to completely avoid retractions if you don't like them, and that is to submit to the Journal of Universal Rejection, which just announced its first annual conference, but you should really check out before you make your plane ticket reservations. You'll see why. But that's going to be held in Portland, actually. You don't Emily, you don't have to make any arrangements, so you can actually go to it or not go to it, as the case may be. Obviously tongue in cheek, but it's funny as hell. Adam and I love this thing. So I'm done. That's how to reach me, and thanks to someone who always helps me with my slides. So thanks.
Thank you, Ivan. Are you going to do on this computer or? Yeah, okay. Our next speaker is Cesar Barrios Sotero from Faculty of 1000, talking about their post-publication review system, which I hope is on here somewhere.
Yeah, it's one of these two. This one. Thanks, Jonathan. My name is Cesar Barrios, and I'm the Outreach Director for F1000 Research. F1000 Research is one of 3 products currently published by Faculty of 1000. You might know us by our signature product, F1000 Prime, which is a directory of recommendations of the best research in biology and medicine from a faculty of global experts, which is somewhat similar to PubPeer and PubMed Commons, in that this faculty of global experts rates and recommends the top articles in their field. Our second product is F1000 Posters, which is an open access repository for posters and slide presentations in biology and medicine. And F1000 Research, which is an open science journal for life sciences that was released in January 2013. And some of the key features of the journal include that all data is included with every publication that is submitted to the journal. We also have fast publication times, usually within a week or less, enabled by a transparent post-publication and invited peer review process. And because we believe that all sound science should see the light of day, regardless of whether the results are sexy or not, we publish a wide array of articles, including single findings, case reports, protocols, replications, non-negative results, and more traditional articles. Now, we can all agree that there have been significant advances in publication since the first journal came out more than 300 years ago. However, the peer review process itself hasn't undergone major revisions since it was formalized in the mid-20th century. And for the most part, we can agree it sort of feels like what you see in this cartoon, right? It's a very nerve-wracking process that I'm willing to bet that no scientist really enjoys. And actually, a few weeks ago, a very interesting conversation was started on Twitter with the hashtag 6-word peer review, in which hundreds of scientists chimed in and expressed their displeasure at the current state of peer review. Now, I'm not going to go through how traditional peer review works, because I'm sure that you're all very familiar with it. But I am going to point out some of its shortcomings. For example, lack of transparency, because most of the time it's anonymous. You don't know who the reviewers are or what happened with the paper before it was accepted. There's also a lack of accountability, again, because the reviewers are a lot of the time anonymous. And sometimes the editorial decisions don't actually reflect the reviewer comments. There's also inefficiency and delay built into the system, because re-reviewing the same work takes time, and sometimes an author has to resubmit to a different journal. There are also, as I said, delays built into the system. Some of them might be incidental, because reviewing takes time, or deliberate by means of reviewers delaying competitors' papers. So in our model, we do things very, very differently. So an author would submit an initial version of their paper to our journal, which goes through an in-house pre-refereeing check that checks for soundness of science, adherence to ethical standards, make sure that's English and it's understandable. And after it passes this in-house pre-refereeing check, it is published online on our website within 7 days after submission. While we're doing this, we're also gathering all the underlying data from the paper and ensuring that it's deposited in the appropriate data repository. After publication, then comes an open and invited peer review process. Parallel but separate to this, we also open the paper for commenting by the scientific community. So once the reviewers take a look at the article, they make comments and give it one of three ratings. Either an approved checkmark rating, which means that the article is sound science and doesn't need any major revisions, maybe minor ones. An approved with reservation question mark, which means that the article is still sound science but needs some major revisions, or not approved X mark, which means that the article is not sound science. So the author receives the comments from the referees and these scores and then submits a second version of the article if it's necessary. And once the article receives sufficient number of these positive marks, meaning either 2 approved checkmark statuses or 1 approved checkmark and 2 approved with reservation question marks, then it's indexed into PubMed, Scopus, and Embase. So I'm just going to go briefly over one example of an article that underwent peer review in our journal. So this particular article was published initially on the 5th of March of 2013. This original version of the article got 3 approved with reservation question marks. The author had a look at the paper, at the referee reports, responded to the referees accordingly, and submitted a second version of the paper. This second version of the paper was then published on the 12th of August of 2013 and received 2 approved check marks from 2 of the reviewers. However, one of the reviewers still gave it an approved with reservation question mark. At this moment, the paper was already indexed, but the author decided to get everybody on board, so he submitted a third version of the paper, which was published on October of 2013. And finally, this convinced this last referee, that the article was up to standards. So at the end of the day, this article received 3 positive approved check marks, 2 from the second version, which roll over into the third version, and 1 from the third version itself. And because we believe in full transparency in our journal, all of these versions, as well as all of the referee reports and author comments, as well as the names and affiliations of the referees, are readily available and freely accessible on our website, as well as on the article itself. They're all attached to the article once it passes peer review. With every version, as well as when it passes peer review. So, with so many versions of an article, you might be wondering, how do you cite such an article? Well, the citations of F1000 research papers actually point to particular versions of the article. In this particular example, in this particular example, if you pay attention, there's a part of the reference, the citation that's in between square brackets. In there, you can find information about the version of the article. This particular version was version 2. And you can find information about the refereeing status. This particular article, this particular version of the article was actually already indexed. Furthermore, if a paper has been updated since it was cited and readers land on an outdated version, a pop-up window like the one you see here comes up that alerts them that a newer version is available. So, what does our approach mean for for authors and readers and reviewers? Well, for authors and readers, you now have a visible discussion between referees and authors that puts the paper into context. For example, it shows the backstory of a paper. Why did it take 3 rounds of reviewing for this paper to pass peer review? Authors can now demonstrate that their paper was reviewed by top people in their field, because everything is open and everyone is named. This reduces bias amongst referees. And of course, there's a strong educational core to the whole endeavor, because now these open referee reports can serve as examples on how to perform peer review. Finally, for the reviewers on the other side of the equation, they can now take credit for the hard work. They can demonstrate their experience as a reviewer and show their informed opinion of the work as a peer in the field. and where they thought it could be improved, which is especially relevant in borderline cases where an article just barely passed peer review. So using our post-publication peer review model, at F1000 Research, we guarantee speed of publication. As I said, articles are published within 7 days of submission. Because we publish a wide array of work, authors can get more credit for their research. And our transparent peer review process also reduces bias and improves the quality of reviews. So I probably skipped over a lot of details of our model, but if you have any questions, feel free to approach me or write down my contact information, and I'll be more than happy to answer any questions that you may have.
All right, and our last speaker before the discussion panel is Jonathan Dugan from PLOS, talking about a new, what is it called? Open
evaluation.
Open evaluation from PLOS.
Thank you. Thank you, Jonathan, conference organizers, for the opportunity to speak. My name is Jonathan Dugan. I'm the director of PLOS Labs. Today I'm going to be talking to you about a project called Open Evaluation. So, many of you know PLOS. It's a 10-year-old not-for-profit. We focus on STM publishing. We have 7 journals. We published one journal called PLOS One that was somewhat of a leader in this idea of the mega journal where all valid science is published. PLOS has been a pioneer in this movement for open access, and our mission is around transforming research communication. PLOS Labs is a small innovation group we opened up within the last year. Our remit is to design, build, and test product prototypes. So we take ideas specific around disruptive innovation, build out a prototype, and then test it in front of researchers. And then projects that come out of labs either go into PLOS, become products, or are released out into the community for the scientific community to take forward. And there are some other areas that we're looking at. So when I first arrived at PLOS, evaluation was the project given to me by the board. They said, we want you to take a look at how papers are being evaluated, pull into this question how PLOS One works, and let's reevaluate evaluation from the ground up. So after several months and a lot of testing, we came through this project called Open Evaluation. The status of it now is the prototype is built, it's tested. We're finishing up all of the reports and recommendations now to PLOS and starting to tell the rest of the community about what we've built. So generally, no one collects feedback from researchers who've read a paper. It happens all the time. Researchers have feedback, but for the most part, the scientific community keeps those opinions about particular work within small communities. It's not necessarily made transparent to the rest of the community. We've heard today from several of the speakers around reproducibility, retractions, lots of issues that peer review has, and while it's the best system we have, we know that we can do better. PLOS strives to foster this atmosphere of experimentation, and we know that with each of these different experiments that we do, we can build better tools and services. But most importantly, the idea of open evaluation, that scientists can in an open way evaluate each other's work, opens up new models for publishing. And I mean, very closely related to this kind of new model is what you just heard from Faculty 1000, where they're saying documents can get actually published, made accessible within a period of days. This was also one of the drivers for this project at PLOS. We started out with the design of this novel evaluation tool. Essentially, we looked at it as, let's not change peer review, let's make a system online that takes advantage of more modern internet communication norms, people communicating faster, shorter, and in more structured ways, and ask the scientific community, how can you evaluate each other's work differently? Not sitting down, taking several weeks, writing up an unstructured block of text, but going in online, clicking buttons, and in a very short period of time, putting out open data identified with the reviewer, and seeing how that would work. So we came up with a tool. It has 4 structured collection areas and a 5th that is unstructured. The first 2 areas are areas that are associated with what we typically think of the system of journal titles now. So we actually ask the person, what is your interest in this article? And I'll show you some examples of what the scales look like in a minute. But typically, the interest of a particular article is being encoded in which journal the paper appears in, as opposed to sort of the mega journal model where all of the science is there and then there's a post hoc need to figure out who's interested in what area. Also, the importance of a particular article, again, this is typically encoded now into this hierarchy of journals. So if the article is appearing in an important journal, then we make this expectation that that must be an important article. The other 2 factors that we collect from evaluators are the 2 basic questions that are happening in traditional peer review. Do you believe it? Is this a valid work of science? And was it presented well? And I'm going to give you some examples of, in a minute, what these scales look like. The 5th area we collect is unstructured, and we ask, what's the ideal journal for this work? Who would be interested in this work? And what are some search queries? So these are some free text areas where people can put information in the prototype we were testing, but there's a variety of systems that we expect this can get tied into other PLOS products. So as an example, this is all of the data in one of the questions. So the 3rd question around validity of the scientific work. We actually, I don't have time today to give you a live demo, but the actual design of the interface of this doesn't present all of this to the user. It's actually just one question where the user is asked to rate the article on a low to high scale, with 2 elements of the scale being low, somewhat negative, and 2 elements of the scale being positive. And we decided not to use a numerical rating or a star rating, but instead actually use categorical phrases to define each of the scale elements. We also present it in a way that matches an initial response from the reader. So there's just one element they have to click. So it's, yes, I think this work is reliable, the 3rd question. And then additional structured areas are presented. We actually came up with these structured areas on each of these 4 structured areas from a review of a corpus of peer reviews by going through and coding each of the peer reviews. So this is an example of the 3rd question around scientific merit. This is an example of what we ask in the presentation in Clarity. There are spaces for unstructured text, and there's also a mechanism by which authors can respond to these evaluations. If you want more information on this, we have a website up. You can go to ploslabs.org. There's some videos. There's more details. I'll put these slides up on that page, and we've run a variety of beta tests. We're not our last beta test actually is complete at this point, but we're still signing people up for future projects that Labs is testing. So how is this system different than traditional peer review? We designed it to be simple. So in our most recent beta test, most people filled this out within about 2 to 5 minutes. It's structured, so it can be coded and read, and the data could be aggregated. It's transparent. The process of what people are being asked and the output of this, we expect, at least in our implementation, will be CC0 open data. We designed it to be applicable for pre or post publication, so it's a tool that we can collect these evaluations over time. We hope that on the order of 10 to 50 of these would be enough to be a surrogate for a scientific consensus around a paper. We also designed the tool to be general to a variety of scientific research outputs, so primarily focused on articles, but other types of research outputs like at conferences or videos. Again, potential for larger numbers of peers doing this instead of the typical 1, 2, or 3 in a peer review process, and again, much more open than the existing systems. We invited a variety of people in for testing sessions at PLOS. We invited researchers in to do interviews. We conducted a series of about 100 remote online user tests. Again, the qualitative analysis going through peer reviews and coding them. And then we iterated this over a period of several months and then did a large beta test with the PLOS One academic editors. In total, we've worked on this for about 9 months and communicated with over 1,000 people. We found that the tool is actually easy to use. People are interested in using it. It's simple. The choice of actually using a 4-point scale prevented people from being ambivalent. They actually had to say, I think this is a useful thing, or I think there's an issue here. We found that there's a pretty significant education need. Whenever we talked to any researchers and brought them in to use some sort of new system, every single time their mind went back to, this is how I think about peer review. It's going to take me 3.5 weeks. I have to do a lot of analysis and drill deep. And this is a model that is different than that. This is asking a larger number of people to give a structured short input and then be able to aggregate those results. I don't have time to go into them today in the last 70 seconds, but the incentives are critical. How to get people to do this. There's the reviewers, there's the authors, there's the publishers, there's the funders. There's a variety of people in this whole ecosystem. Our next steps are talking with publishers and preprint services, service providers, so the tools that are actually displaying papers and making them accessible online, funders and government agencies, around the idea of what we want to do with this kind of evaluation system. Where our next steps are building out the products and services within PLOS so that when this model is working, PLOS can be receptive to the papers coming in this way. A lot of that is working through what the policy is going to be for how we can take papers with a bunch of evaluations that come to us and get them out quickly, how we're going to handle papers down the line post-publication if there's significantly negative reviews from the scientific community, and then roll out the services. Thank you. I'm available the rest of today and tomorrow if you have questions or want more information.
We have if the speakers can come up, we have a few minutes at least for some discussion. I don't know if you want to launch it off, or I have a question, or...
Well, what I thought, since I'm really loath to run into anyone's break, so we're going to end it at exactly on time. Since we had 5 panelists each giving presentations, we have a little bit less time for discussion. So I think the best thing to do is just throw this out to the audience and take questions and just do what we can in the next few minutes. So if anyone has questions for any of the panelists. Jonathan.
No one's ready, Alex. One thing that I didn't hear in the discussion today that I think would be worth discussing what your thoughts are on is blinding reviews to who the authors are. So we've talked a lot about revealing who the reviewers are, but there's also been a discussion in some contexts about trying to have the review process be double-blind, basically, in some sense, or at least trying to remove some of the potential biases in evaluating. And I'm wondering if any of the people on the panel have experience with this.
So that discussion came up in PLOS, and it was quickly shut down for technical reasons, where it was just a really hard thing to actually blind them. As soon as someone said, our previous work from last year, and they cite their own paper, plus the sometimes small communities around who's going to be the evaluator, just looking at the paper and what they're working on, there was the expectation the reviewers would actually just know who they were, but there may be other places doing that I don't know about.
I'd also like to respond. So at the journal that can you all hear me? Okay. The journal I work with, we use an open peer review process, or at least we consider open peer review. And the way that it actually works is all of the reviewers and editors are on a Google Doc, and you can go back and forth and actually have a discussion. There's a period of time, but not necessarily. So an author can actually have a longer conversation with a reviewer than just, here's your block of text, and here's my editor stripping out all of the information about the review that I'm getting, so that an author can actually have a discussion with a reviewer instead of it being mediated by an editor as well. And I think the accountability, there are a lot of reports, at least in terms of the arguments made for open peer review, that there's abuse, reviewer abuse, in reviews, where they're, because you don't know who you're responding to, you're not very nice, right? So having a human behind it, I think, also maybe makes us a little bit more polite when we have some harsher things to say, and sometimes those harsher things still get said, but they're framed in a way that are much more acceptable, and an author can actually have discourse as to what that means. There are still people who are very concerned about implicit bias, however, and I've had many discussions with people about that.
I've certainly seen that, like people who are perfectly nice in person are just livid when they write back to reviewers. The other thing, I think it also works both ways, and I think part of the motivation that some journals have, at least my understanding, for having a transparent peer review process is that the reviewers were actually abusive towards the authors, particularly very high impact journals with very junior authors, and apparently reviewers would essentially get some of their research agenda enacted by the person who wants to be published, and it would be 6 months of further experiments and so on, and it was just actually an unfair situation to the person trying to get published. And I think another thing we haven't talked about much is how do changes in peer review affect people who are very junior versus people who are very senior? And I think they're very different pools. So something like having to reveal your name as a reviewer, I haven't seen any empirical evidence on this. I would guess that's a more comfortable situation for a more senior person than a junior person. So there's sort of this differential impact and willingness to kind of reveal, I guess.
Actually, touching upon that real quick, one of the things that we do out of 1000 Research is sort of, let's say, protect more junior reviewers, is that they can actually co-author their review with a more senior researcher to sort of prevent these problems that you're pointing.
I saw one just behind you. I saw one question.
I still don't, after I listen to you, understand what is the logic for evaluation. Does it do something in terms of improving the argument, or does it do something to improve the administration of people? So what is behind this sort of, if I listen to Jonathan's talk, I think about it, it is the number of people who say something, but then I do not know whether what they talk about is better or not. It only tells me something about people agree and don't agree, but I don't have any argument. So therefore, I keep wondering whether the same thing happened without any peer review, that I, as an editor of a journal, I'm responsible for any article that is published, and somebody gives a vicious remark. Why aren't there any longer vicious remarks? Why don't people write like, I don't know, if you look back in the early 1920s, my esteemed colleague is the most boneheaded chemist I've ever had the pleasure to review, you know? So there is not there is no argumentation, so there is some hiding feel behind this evaluation for what? Why does status has to play a role in arguments? So, and status means that obviously the purpose of evaluation is not scientifically driven, but it is something else, and that is what I'm trying, which I fail to understand. Sort of, what purpose does it serve?
We're academics, and academics is political, so I would just, that plays into it, I would assume.
But then make a political argument and not a scientific argument. I mean, if it is political, then have a political argument, and then you can decide, and political arguments are decided by majority and minorities. Or we have a moral argument, I don't like your argument, I don't like yours. Or we have whatever argument, or we have an academic argument which says you do not know how to do your work. So these are very different modes of communication in relationship to what I would like to get out of that debate. And so therefore I have to still try to find out what do evaluations do that without this evaluation could not be had. So that's what I try to get from it.
Just in our limited time, we'll take, I think you had a question right in front.
Yeah, Russell Netches, UC Davis. So I asked a somewhat peevish question on Twitter, which is, how many papers in the retraction literature have themselves been retracted? But more seriously, are retractions reviewed, and what should be done when retractions are in dispute?
Sure. So I know it was a peevish question, but in the interest of transparency, the paper that I mentioned as being sort of the maybe most important, or whatever the word I used, it did have a correction. There was a typo in it. So a lot of people who didn't like that paper jumped all over it, as you'd expect. There have been a couple of retracted retractions, but there have not been any retracted papers about retractions. So I don't think that I can get any more meta than I just did. I should be spanked for that. But I think, you know, your question in terms of disputed retractions, you know, there are guidelines for these things, and to answer briefly, because in this time, I'm sorry, this is too close or too far. Am I too close or too far? Oh, it's. So, you know, their Committee on Publication Ethics has guidelines for disputes between authors, and then they also have separate retraction guidelines and correction guidelines as well. You know, what I think should be done is the most transparent thing you can do, and what that generally would mean is a narrative. I mean, there's no space. There are no space limitations here. Let's just have, here's what one person here thinks, here's what another person thinks. But based on our responses from some editors and authors, transparency doesn't seem to be the main concern of most of the people who don't want to talk to us, obviously. So it's very bimodal. There are people who are very willing, and we actually have a category called doing the right thing, which we created at the suggestion of one of our commenters, saying, you know, let's reward good behavior, which is sort of what I was getting at with that paper that I mentioned. But then we have a lot of people who don't want to talk to us. So it's just it's human. I don't know. It actually kind of gets back to this political versus all of those questions, I think. You know, it's a hard one.
Yes, if you still have your question.
Sure. I guess the question I have is really about, I mean, I think it comes back to some of the issues that were just raised about what criteria should we be using when we look at different models of peer review or review to determine what gets, quote unquote, published where. And should they change in an era in which we no longer have the scarcity that was imposed when publication meant publication in print? And so I think everybody on the panel could comment on how they think about that process. So how should we evaluate the experiments that you're describing? How would we know if they're better? Better than what?
Yeah, go ahead.
I'll tell you how we came about that question. It comes down to a really simple metric. Is science working better? And we think more about that in terms of the scientific community and researchers and the sum share of shared knowledge and how fast we can aggregate it and move it forward. Unfortunately, that's a little bit of a conflict of interest with regard to the organizational interests of the organizations that make money or just make a surplus and keep the organization running as publishers. So one of my slides that I took out for the interest of time was a diagram showing that the publishers are actually outside of the scientific community, and all these different projects that are sort of bringing some of them closer to the science community and some of them that are overlapping. But yeah, that's our guiding principle there does it make science work better?
I'd like to jump in. I'd like to say, you know, I think it depends on what's the goal. The goal for me is to create discourse, right? So peer review is a discourse process. And so that in and of itself, new knowledge is being generated within that conversation happening between authors and referees. And that's what I think, at least for me, at the journal that I work with, it's about that discourse. And then that discourse comes out in the final product. So that's, I think it's the approach to it there. In terms of assessing how we're successful or not, there have been papers, there are papers that have been written about peer review processes, and there's all the statistical analyses that I don't understand, but they're there. It sounds like there are a lot of scientists or statisticians in the room. Maybe you can make sense of it, but I think that's something that we need to see. And also because open peer review processes or peer review processes are different in every discipline and for every journal, each one might have its own assessment metric. So I don't think there would be one standard way that you could assess an experiment, because they're all trying to move towards a different goal.
So there
I would just say, I'm sorry, really briefly, just on the second or whatever part of your question in terms of deciding where something should get published. I mean, and I haven't studied enough to endorse it or not endorse it, but Rubric is sort of trying to do that, right? And actually helping people, you can take your reviews from one place to another, which saves time, you know, theoretically, that's their argument. And then it can actually predict for you where a paper should go, which most people in the field probably are pretty good at, but supposedly they have a rubric, so.
So there was one question, I think there was a woman I saw with her hand up. No. Yes, okay.
It scared me when I heard Ivan say that he constantly gets notices from people who think papers should be retracted. And it leads me to think about, you know, what I think Josh was talking about, that you know, there have been a lot of studies, and a friend of mine and who I follow, his blog, who is the former editor of BMJ, Richard Smith, who probably many of you are familiar with, he constantly talks about the fact that you know, when he was the editor, he seeded journals with mistakes, journal papers with mistakes to see if reviewers would catch them, and 90% of the time they didn't. I mean, the numbers were shocking, and there are many papers about this, and he just recently wrote a blog post saying, why don't scientists care about this or talk about this all the time? It's so shocking when you think about the amount of time that goes into peer review and the many careers that can be made or broken by peer review, that it just, you know, it's just, it's blown away by everybody pretty much. So I think it's an important question. I don't claim to know very much about it, except these posts that I've read.
I think that's actually a terrific comment to wrap up with. We're a couple of minutes over, so maybe we can close the session and thank all our panelists.